We offer you deep historical information from history on YouTube channel. Subscribe. Now don't forget to turn on notifications.
Solar flares and their historical impact, the wrath of the sun. The sun is not only a life-giving star, but also a celestial body that sometimes shows its anger. The most tangible manifestation of this anger is known as solar flares. Solar flares are huge bursts of energy that occur in the sun's corona as a result of the sudden reorganization of its magnetic field lines. These flares can also affect the Earth by ejecting radiation, plasma, and charged particles into space. Solar flares vary in size and intensity. While small flares have little effect on the Earth, large flares can damage power grids and electronic equipment, disrupt radio and satellite communications, and even cause errors in GPS systems. Solar flares are also known to have had a significant impact on mankind throughout history. Impact of solar flares throughout history: 1859 Carrington event. The Carrington event, considered to be one of the largest solar flares in history, took place in 1859. The eruption caused magnetic storms on Earth, causing sparks on telegraph lines and auroras visible even at the equator. The effects of the eruption knocked out many telegraph lines and caused blackouts in some regions. 1921 Aurora Borealis event. The 1921 solar flare caused the Aurora Borealis, northern lights, to be seen in an extraordinary way on Earth. The flare lit up the skies over the northeastern United States and much of Europe. 1989 Quebec blackout. In 1989, a major blackout in Quebec, Canada, was attributed to a magnetic storm caused by a solar flare. The flare caused extensive damage to the city's power grid, leaving 6 million people in the dark for 9 hours. 2003 Halloween solar flare. The 2003 Halloween solar flare was recorded as one of the closest solar flares to Earth. The flare caused disruption to satellite communications and GPS systems. Precautions against solar flares. Predicting the effects of solar flares in advance and taking the necessary precautions is very important to minimize possible damage. Space and solar observations help to predict solar flares. Another important precaution is to protect power grids and electronic equipment from solar flares. Solar flares are a reminder of the power of nature and our place in the universe. Increasing scientific research and measures to minimize the effects of these events is important for the future of humanity. The Carrington incident of 1859, a historic manifestation of the sun's wrath. The Carrington event of 1859 is considered one of the largest solar flares to occur on the sun and affect the Earth. Observed by British astronomer Richard Carrington on 1st September 1859, it caused magnetic storms on Earth and the extraordinary sighting of the Aurora Borealis, northern lights. Characteristics of the eruption. The eruption took place in the sun's corona, in the region of a large sunspot. As a result of the explosion, large amounts of radiation, plasma, and charged particles were ejected into space. The intensity of the explosion is estimated to have been in the order of X20, using today's class G5. Effects on Earth. Magnetic storms. The explosion affected the Earth's magnetic field, causing magnetic storms. These storms caused sparks on telegraph lines and northern lights to be seen even at the equator. Blackouts. The effects of the explosion knocked out many telegraph lines and caused blackouts in some regions. Northern lights. The explosion caused an extraordinary display of the northern lights. This event lit up the skies in the northeast of the United States and much of Europe. Significance of the Carrington event. The Carrington event was the first major event to show how large an impact solar flares can have on Earth. This event stimulated the scientific study of solar storms and the Aurora Borealis. Today, studies are being carried out in areas such as solar flare, early warning systems, and power grid protection. The 1921 Aurora Borealis, the spectacular show in the sky. The 1921 Aurora Borealis event was a series of powerful solar flares on the sun on 15 to 16 May 1921 that caused a spectacular display of light on Earth known as the Aurora Borealis, Northern Lights. This event is considered to be one of the largest auroral events observed in the 20th century. Characteristics of the eruptions. 3 consecutive large solar flares occurred on the sun on 15-16 May. The flares ejected large amounts of radiation, plasma, and charged particles into space. The intensity of the flares is estimated to have been at the X20 level when measured in today's G5 class. Northern Lights event. Due to the effects of the explosions, an Aurora Borealis event took place in which the Northern Lights were seen in an extraordinary way. This event lit up the skies in the northeastern United States, Canada, and much of Europe. The lights were so bright and vivid that people could see the night as if it were day. Impact of the event. The 1921 Aurora Borealis was not only an event of natural beauty, but also of scientific significance. It helped us to better understand the relationship between solar flares and the Aurora Borealis. It also gave a boost to the scientific study of solar storms and the Aurora Borealis event. Historical significance of the event. The 1921 auroral event is one of the largest auroral events observed in the 20th century. This event helped us to better understand the relationship between solar flares and the Aurora Borealis. It also stimulated the scientific study of solar storms and the Aurora Borealis event. 1989 blackout in Quebec, the devastating effects of a solar storm. On 13th of March 1989, a major blackout in and around Quebec, Canada, was attributed to a magnetic storm caused by a solar flare. This event was recorded as one of the largest blackouts in modern history, leaving 6 million people in the dark for 9 hours. Cause of the event. On 10th of March 1989, there was a powerful explosion on the sun. As a result of the explosion, a large amount of radiation and charged particles were thrown towards the Earth. These particles affected the Earth's magnetic field, causing magnetic storms. Effects of the blackout. Major damage to the power grid in and around Quebec City. 6 million people lost power for 9 hours. Hospitals, airports, and other critical infrastructure were also affected. Economic losses were estimated at more than $1 billion. The aftermath. It took days to repair the power grid. In the aftermath of the incident, the potential impact of solar flares and magnetic storms on power grids was studied. New measures were developed to protect power grids from solar storms. Significance of the event. The 1989 Quebec blackout is an important event that demonstrates how solar flares and magnetic storms can have a major impact on critical infrastructure. This event contributed to increased awareness and the development of new measures to protect against solar storms. Lessons learned from the event. More research and investment is needed to protect power grids from solar storms. Early warning systems for solar flares and magnetic storms should be developed and disseminated. Critical infrastructure should be made more resilient to solar storms. The Quebec blackout of 1989 is an important warning of the dangers that solar storms and space weather can pose to humanity. The lessons learned from this event are essential to minimize the damage caused by future solar storms. 2003 Halloween solar flare, the frightening gift of the sun. On 28th of October 2003, a powerful explosion on the sun was dubbed the Halloween solar flare. This explosion was recorded as one of the closest to Earth and caused disruption to space and satellite communications and GPS systems. Characteristics of the eruption. The explosion took place in the sun's corona, in the region of a large sunspot. The explosion ejected a large amount of radiation, plasma, and charged particles into space. The intensity of the explosion is estimated to have been at the level of X28, using today's class G5, effects on Earth, space and satellite communications. The explosion caused disruption to space and satellite communications. Many satellites were affected by radiation from the explosion, and some satellites experienced temporary malfunctions. GPS systems. The explosion caused disruptions to GPS systems. GPS signals were affected by disruptions in the ionosphere caused by the explosion, and GPS reception was weakened or completely lost in some areas. Power grids. The explosion caused fluctuations in some power grids. Aftermath of the explosion. The effects of the explosion lasted for several days. Space and satellite communication systems and GPS systems recovered from the effects of the explosion. The fluctuations in the power grids were eliminated. Significance of the event. The Halloween 2003 solar flare was a significant event that demonstrated the impact of solar flares on space and satellite communications, GPS systems and power grids. This event contributed to increased awareness and the development of new measures to protect against solar storms. Lessons learned from the event: space and satellite communications and GPS systems should be made more resilient to solar storms. Electricity grids should be designed to protect against solar storms. Early warning systems for solar flares and space weather should be developed and disseminated. The Halloween 2003 solar flare is an important warning of the dangers that solar storms and space weather can pose to humanity. The lessons learned from this event are essential to minimize the damage caused by future solar storms. The world was rocked by the most powerful geomagnetic storm in recent years. The storm, which mainly affected North America, could make it possible to monitor the aurora borealis, including in Turkey. According to a statement by the National Oceanic and Atmospheric Administration, this storm has a high potential to cause problems with electronic devices. The National Oceanic and Atmospheric Administration, NOAA, issued a statement about the solar explosion. The statement warned that the geomagnetic storm could cause problems with electronic devices. Such storms are usually caused by charged particles coming from the sun to Earth, interacting with the atmosphere, and can trigger magnetic storms. The storm came from a spot 20 times the size of the Earth. A few days earlier, a solar flare had sent a huge stream of particles directly towards the Earth. Scientists who track geomagnetic storms had predicted that a solar storm could hit the planet after this event. However, such a powerful storm was not predicted. Analyses show that the storm is in fact the strongest example in the last 6 years. It is also the strongest storm produced by the last phase of the sun, which began in December 2019. This point had previously produced a series of solar storms moving at speeds of around 2.1 million kilometers per hour. The sun's storm cycle. Every 11 years, the star completes a quiet or stormy cycle and begins a new one. The sun is known to have entered its 25th cycle in 2019. Astronomers say that the explosions on the sun will gradually increase and peak in a few years. This is because the sun is currently in an active phase. A solar storm is a geomagnetic storm caused by charged particles and radiation waves reaching the Earth as a result of powerful eruptions on the sun. These storms can cause various problems by interacting with the Earth's magnetic field. Causes of solar storms: coronal mass ejections, CMEs, and solar flares are the main causes of solar storms. CMEs are large clouds of plasma that break off from the sun's corona and are ejected into space. Solar flares are bursts of energy caused by a sudden rearrangement of the sun's magnetic field. Effects of solar storms, damage to power grids and electronic equipment. High voltage surges from solar storms can cause damage to power grids and electronic equipment, disruption to radio and satellite communications. Solar storms can disrupt radio signals and satellite communications. GPS system failures. Solar storms can affect GPS signals, causing errors in GPS systems. Northern lights. Solar storms can cause light displays in the Earth's atmosphere, known as the aurora borealis. Northern lights. Protection from solar storms. Protection of power grids and electronics. It is important to protect power grids and electronic equipment from solar storms. Early warning systems. Early warning systems for solar flares and solar storms should be developed and expanded. Space research. Space research should continue to better understand solar storms and predict their effects. Solar storms are a reminder of the power of nature and our place in the universe. Increasing scientific research and measures to minimize the effects of these events is important for the future of humanity.
We offer you deep historical information from history on YouTube channel. Subscribe. Now don't forget to turn on notifications.